Okay, welcome back everybody. So, okay, so let's do the following. So we have a specific question now on how to save things once you actually develop your code. Okay, so in principle, what you're looking at once you are opening, I close now all the file, I close all the scripts here, Daryl. Just go along with me. Okay, so you open, oh wait, actually no, we don't need to close it. So you basically open RStudio. What you will see here is the console on the right upper quadrant, the so-called global environment or environment, where you have environment, history, connections,
tutorials.
And here the tutorials, yeah.
Right.
So then on the right lower bottom, you have here your plots, you have the files, you have the packages, you have the help and the viewer, right? So here the console is really, which you have to understand in two separate aspects. So you have here, when you go on file, which you can do, right? On file, you go on new file, you can go on our script. So this is a script. Good. If you go on file, new, and you go on our markdown, it will prompt you here, what do you want to do? And you go on PDF, you select PDF, and you name this somehow. This is like test. You click OK. It will create you a markdown file named untitled2.titled test. Is that working for you?
Yes. Okay.
Okay, great.
Yes.
Okay. Okay. So now you go on.
How do I submit that in Blackboard?
Just a second. Okay. So now we go on File. Now we go on Save As. Now we find the folder we want to save it in. I go in CUNY, teaching, grammar, classes, 5, and lab. And I create here a new folder, which is the folder test. Okay? So we know now this is in test. So this markdown file I'm saving in test. I go now on the script. I go on, I write something in it. And then I go on Save As. I am in the same folder, right? So I'm already starting in that folder. So now I want to write it, I want to save it in that folder. I save it. Now go and find it, which is for you the Internet or Windows Explorer, right? So here find my folder, and here I have a .r file and .rmd file. Good. So if I go back, so the R file is a script, right? So if I load here a data file in there, and I load the empty cars data file, oops. I'm having now a data file in there where I can say, what does it contain? Empty cars. And I create anything, I do not LM or AM, not LM, MPG as a function of AM data equals empty cars. So this is now a model. So I develop now a model, right? So once you have, okay, so in the script, you only write the code. You're running it in your console. In the object, you populate automatically whatever you're loading in your script. And here you basically display whatever you ran. So if you go on, so this is test. This is our R script, test.r. You save this, and this is your script, a standalone script. If you go on untitled RMD, and this is now where I think your problem comes in. You can go here on knit, and you knit it to PDF. That is basically now computing the RMD, the markdown file, and is creating now a resulting document based on that markdown code.
Okay.
And this is located in the same folder as your markdown file. So this is now the PDF.
Mm.
And the submission should contain the RMD file and the PDF. Okay.
Okay, that was my problem.
Is your problem solved now?
Yes, it is.
Okay.
Yes.
Then submit it ASAP, and then I give you another point. I give you a point back.
Thank you.
And of course, but please, in questions like that, please really utilize the discussion board and communicate directly what you want, and let's schedule one-on-one. Don't wait until the deadline passes. I think that it would be good. We kind of touch base when an immediate problem like that.
I thank you so much. Yes.
Yeah, no, of course. Just I really want to make myself available, and I try to squeeze you guys in as good as I can. So please give me an opportunity to do so. Let me know if there's a problem. Okay.
All right.
Problems are there to be fixed. So let's fix the problems. Okay, good. R squared. So I understand that it's basically quite early to go too deep into much of the material. You may not have had time to look at the lab. Is there a benefit? And I'm Shitar, Darren. Would you think that I should make lab and homework? Should I change? Let's put it that way. Should I change the posting algorithm? Should I rather post it on a Friday rather than on a Sunday evening? Would that make the Monday morning class a little bit better, the Monday evening class more reasonable?
That would be helpful.
Yeah.
Yeah, I think so. If you post it on a Friday, yeah.
So I'm posting the lecture already on a Friday. Okay, we can do that. That's fine. That's not a problem. But I will leave the due dates then. Okay, I leave the due dates, but I give you the material already earlier that you can prepare yourself over the weekend for the Monday class. Let's do that.
That sounds good, Professor.
Yeah. Okay. So
that works for me too.
Okay, I leave the deadline. I give you 2 days more that you can review the lectures over the weekend. That kind of makes sense. So it's just I'm saying this because now things are getting real, right? So so there is now, if you look at the syllabus, you can see that we are now posting various different assignments, not just the regular assignments. So there will be no assignment for lab 7 next week, but there's a midterm due next week. And I just want to flag this, that you don't oversee that. So we have here, so we are now at 5 and 6. So you have now the homework 1 assigned to you. This is due next week on Monday at midnight. So I left it for Monday, so we can check in next week, Monday, to resolve issues you may have for the homework. Just make sure that you don't forget about this deadline. So that's point 1. Point number 2 is Sunday next week on 6:20, you have an exam 1 going online, which is going to be due on 6/26. And that basically halves our semester. So we are already at mid time of our lecture, and these times I will do my other best to go above and beyond to be accessible and available. We can even do a 3rd review session for next week then. I just really want to make sure that you're doing well on the exam. So please make sure that you have specific questions and that you review this lecture in much detail. Not going to sugarcoat it. The exam is not easy, so please make sure to review things well. So as you know, you can use the script and the lecture notes, and there will be no coding, but there will be a logical interpretation of what we have learned. That means that there will be interpretations and calculations to be done based on outputs from statistical software.
Just
so
to
interpretation. Yes.
Good morning, Professor, or good afternoon, I should say.
Sorry.
Hi. You said that there would not be coding, it would just be logical interpretations. Is that correct?
Yes, you don't need to code. You need to understand code. So there may be some code snippets that you need to interpret, but it's not that you don't have to code. I mean, you're not being asked to become expert coders overnight, but this is your first taste of R coding. So this is applied biostats. Is really it's very nicely organized. The labs are really great. So Marcel Lambino and Professor Sang have done a great job setting this class up, and it is setting your first stage for you to get an exposure to R. You will have BIOS2 is going to be again R programming, and this will be more of a challenge because the things we're learning now are basically a prerequisite for that course. So, but again, this is the importance of the coding in this class. But this class is really mainly aiming at the understanding of how does an R output look like? How do you interpret the coefficients? What is a standard error in an output to understand the basics of it? Okay, so this is how the exam will be designed. Also next week so now on Friday, I'm going to post it on Friday. Next week on Friday, class 7 will go online. The exam I'm going to set online starting Sunday. So this will be available at midnight on Sunday night. And you will have until 6/26, which is the Sunday at midnight. You will have class 7 online over the weekend already. So you can review class 7 starting on Friday up until you take the midterm. I highly recommend to not wait too long. I would really like try to make sure that you take it by like Saturday the latest. I'll make sure that I'm going to be online in case there's any hiccups, any problems. Do not submit the exam. This happened in the past. Do not submit the exam before you haven't finished and answered every question. It cannot be restarted once it started, and it will keep on ticking. It's a 120 minutes exam. It's ample time. You can do calculations, but it will start ticking. So you cannot stop and restart. Good. Homework 1 has posted. Maybe let's also use the time to. Okay, Shital, also okay if we wait for the askware, then I quickly go through homework 1, that you can get an idea of what's asked in homework 1. So, sure. Yeah, okay, great. So, homework 1. So, homework 1 essentially, and this is already meaning to prepare you for the midterm exam. So this is really how you will be presented with questions, right? So you have here an output of a linear regression model. You have here, just like we did in the lab, you have here education, you have gender as a factor with the actual value presented. So if you have female, and it actually should be sex rather than gender. So if you have female, your reference value is actually male. So you know now that females to have millimeter Hg is the outcome, I believe. Yeah, the systolic blood pressure in millimeter Hg is 3 millimeter Hg lower in females. Then you have age, so there's an increase in blood pressure with age, 0.5. Remember, it's with each unit of increase. So here you have a specific example. So make sure that you understand, and we did the calculation last time. You remember how we calculated it in that Excel spreadsheet? This is exactly what this example is asking you to do. It asks you, how can you calculate an actual blood pressure for an individual? with characteristics X, Y, C, and you're meaning to calculate the actual blood pressure. Then you calculate from the observed blood pressure the residual blood pressure. So the residual is the difference between observed and predicted. Then we have the value for predicted. If you have a second individual, you calculate from a second individual, you do the same thing. Again, you calculate the residual. So it's easy, right? It's not terrible. Just make sure to set it up right. And this is where it's not coding, but there's where calculation will be necessary. So you're being asked to actually do calculations in Excel. Then you are being asked here to calculate the total sum of squares, which you also know how to do. So you have here the calculation of how to derive the variances. You have the sum of squared residuals. You can calculate R squared, and this is what we're going to get to in a second. So then here you calculate the R squared for this regression analysis. Then you have now you're calculating also the differences now between the two education categories, whereas all else being equal, gender and age remains to be constant. Same here, you're again being asked for your differences between the effects of age, gender. Yeah, so you're using now from this regression analysis, you're using the gender difference, which we have seen in the output. Then you have some multiple choice questions. You have some applications on R squared and some open note questions. And here's some questions that will basically quiz you on the assumptions of linear regression, which we have discussed, right? Which is homoscedasticity, normal distribution, independent observations, and independent samples. So, good. Okay, so this was the homework in a very fast overview. Any questions on the homework? I know it was fast, but you will need time to first.
I was hoping, Professor, when you say calculate, can you like give an example of what you mean?
You remember how we did last time, the calculation of, well, we are doing this calculation in Lab 5. So Lab 5 will essentially guide you through the process on how to do those calculations.
Okay.
So in Lab 5, just watch the Lab 5 recording and go through the code. It essentially does exactly that. It will allow for you to do calculations of how to employ actually your coefficient to calculate your actual. So this, for example, so here you have the predicted value, right? So you have, we can quickly look at this. There's the empty cars. Here we have the fit. And here we essentially, so this scatter plot for empty cars. So here you get with the predict function, you get an actual predict for your y hat 0. So y hat 0 is now a prediction of your 32 entries. Y hat 1 is fitted. So that's essentially what you fitted. And this is the calculation using these coefficients that you have found. So if you have here the linear model fit 1, shows you an intercept of minus 5.14. So this is essentially this part of that code. So you have y hat 2 here. Let me zoom in a bit. I recognize this maybe a little small. So you have here y hat 2 is coefficient of fit 1 on the first spot. So you have, again, coefficients with coef, you get to this part of your output. So you have here your linear model, you have coefficients, here you have intercept, and here you have your second outcome, which is QSEC. I'm not sure what that is, to be honest, but I think it's time until, I don't know, acceleration. Maybe it's, I'm not a car guy. I don't really know. Okay, so if you go in coef1 and you indicate here with the parentheses 1, it will take the first entry. You will essentially have the possibility to extract the first entry, which is the intercept. When you take the second entry, you get QSEC, which is the second entry. So if you want to utilize now, so this is again, so 1 and 2, you get these printouts from this model, and you want to calculate and predict now y hat 2 as a list of numbers for each individual entry. And we can look at the environment. So this is your environment. This is your object. You have here, each row is a separate car. So QSEC is this variable, whereas MPG is this variable. So you're predicting MPG as a function of QSEC. So this is essentially here, this model, which is your intercept and your QSEC, which we know from a previous lecture that we have had. I can show you. No, this is the wrong lecture. This is exactly this function, right? Yeah. So this is the function. So this is a simple linear regression where we have the yi. We're predicting each individual entry for our cars, which is each individual MPG equals the beta 0, which is our intercept, plus our slope, which is coefficient 2, multiplied by an xi, so the entry on x, which is essentially each individual entry for QSEC, plus a residual error. So this being said, this is our beta 0, this is the beta 1. So now calculating y hat 2 for each individual car is coef fit 1 plus coef fit 2 multiplied by the individual observation for each of the cars. So adding this up will then in essence get you a vector, which is y hat 2, which is here 1 to 32. So we can look at this. And this is the number of predicted values, which is notably consistent with y hat 1. Right? So this is if it's fitted. So here we have 18.12954, which is consistent with Mazda RX-4, and 18.92, which is consistent with a Mazda RX-4 wagon. I don't know. As I said, I'm not a car guy, but yes. So this is basically how you calculate it. Sorry, I just got quickly. I'm trying to coordinate the work now. Okay, sorry. Okay, does that make it a little clearer what the prediction aspect of it meant? I hope this made things a little bit clearer. So this is the calculation that is being meant. So you can do this in Excel, you can do this in R. It's like I'm totally agnostic which software you're using. But it's essentially, you're predicting an individual level with intercept plus slope multiplied by an individual entry. So going back to the homework, you're doing, You're doing nothing else, right? So you have a linear regression model here, where you have here an intercept. You have here a factor, which is essentially education, which either is somebody who has graduated from high school, which is 5 millimeter HG higher, or has graduated from high school. Remember the dummy variables and the contrasts we discussed. Or he or she graduated from high school, and or he or she graduated from college. Then it's 0. Then this drops out. Then you don't have to add anything for this variable. Now you have somebody who is female or male, and you basically add or subtract. Or you have somebody who is like 70 years old, you basically multiply this with 70 and you add it to your multiple regression model. Does that make it clearer? So it's a different example, a different way of applying the model and to predict actually your outcome variable, which is y hat 2. Does that make it clear?
I have a quick question, Professor, that might have to do. I just want to confirm that I'm understanding correctly. So the formula from this is going to be y equals the intercept.
Intercept plus slope multiplied by the individual x. So it's yi, just to repeat, yi equals beta 0 plus beta 1 multiplied by xi. yi hat, sorry.
So yes. In the homework, that formula is going to come out
of
with
this output, of the output.
Of that.
Correct.
Okay, and so the education, in this example, for example, education might be beta 1, sex and age might be beta 2 and 3 for the confounders. Okay.
Correct. Yeah.
Okay. I just want to make sure I understand.
Yeah. No, you're on the right pathway. So also look back at lab 4 where we have done this as well. So just rewatch the recording and make sure you're on top of this.
Okay.
And this is also lab 5 is perfectly allowing you already to employ this formula. And please make sure that you're really 100% comfortable with this, because this will be the basis then for the second half. Because once we actually start with the multiplicative model, this situation is not getting easier. So just really practice this and really make sure you're very solid on how to extract this coefficient and how to deal with this coefficient. Good.
Yeah, for me,
okay.
R is like so confusing.
Yeah, no, I get that a lot.
Yeah.
Excuse me, Professor. I have another class that kind of like conflicted with this one today at 6.
Yes.
So I'm going to leave this meeting and join the other one, but I will review today's lecture, and I will be submitting that as soon as possible.
Sounds good. Yes. So if you get it out by midnight tonight, I still give you a point. So let's do that.
Okay.
All right. Good. Okay. Great. Good. Thank you, Daryl. Thank you, Zoe, for asking, and Shital. Sorry for having made you wait, but now let's get to the R-square. You're still here, I hope.
Yes,
okay.
Yes. Thank you.
Okay, so thanks for your patience. Okay, so let's R-square. Good. We remember that the correlation coefficient R is essentially, so the correlation coefficient R in principle is, it's the product of the unsquared deviations divided by the product of the sum of squares of x and y. This is essentially indicating in a normal, regular bivariate correlation the strength of the association between the dependent and the independent variable. So now in a simple bivariate correlation, you can just simply square the correlation coefficient, the Pearson correlation coefficient, and you get to a so-called R squared. So now, once you have additional parameters, it's not that easy anymore, because you still have as your underlying basis for your determination, you still have the deviations. And these deviations essentially are being squared to take the direction out and to magnify kind of the difference between predicted and observed values. Squaring this up gets you to sum of squares, and the sum of squares stands for a variability. And what the variability essentially is, you want to explain as much as the variability that you can explain. And you're explaining that by fitting a mathematical function through it, which is a linear function in our simplest linear regression. Right? So by fitting through this line, through your scatter, your bivariate scatter of here, what do we have here? MPG and QSEC. You're fitting a line through this. Outline LM of MPG data MPG is a function of data cars QSEC. By fitting this line through, what happened? Okay, 50 cars. Let's see if that happens. No, did not happen. Okay. Bad example. Never try example. Okay, well, let's do this. Okay, never choose a bad example that you can produce within a second when you want to explain something. Okay, so you have here scatters. You have data points that you have observed, and you mean to explain your population, all the individual observations that you have. You mean to explain it, and you're explaining it by fitting through a linear function, which is y I hat equals B0, your intercept, plus B1 multiplied by X. So this is basically, the regression of a regular function, right? So this is a regression function, simple. So now you have residuals between your observed and your predicted points. These residuals are basically nothing else but your Y, your observed Y, minus your Y hat, your predicted one. So these residuals you mean to minimize or get to zero, as the least square approach does. And I hope you have seen already the recording. So, but bottom line, when it comes to an R square, you're explaining now part of your variability. So you have the variability of your entire scatter. So this is like the mean minus all your individual observations. This is your total sum of squares. This is your total variability. And then you have a variability that is essentially explained away by fitting a regression function through it. And this is your explained variability. And this is the variability which is essentially the inverse of what you still have left as an error. So your residuals are basically the variability of your residuals are basically what you couldn't explain. So the difference between your total sum of squares and your unexplained variability is your explained variability. And this explained variability as a fraction or a proportion of your total variability, that's your R square. So it is a modified way of thinking about the strength of an association, where basically you have like, okay, so there's a scatter here, and then there's a scatter plot. I have a dependent variable, an independent variable. I'm fitting through one function, and I say, okay, so this is my correlation coefficient. Now I'm squaring this up, it's an R square. It's the same principle because you're calculating it as a deviation of x, the sum of deviations of x multiplied by all the deviations of yi, divided by the sum of the product of sum of squares. It's the same principle applies here. You basically take all the residuals and you're basically creating an explained variability. You have these residuals are your leftover unexplained variability. You're subtracting this from your total sum of square, you get to the explained variability, and you're basically dividing this by the total variability, gets you a proportion of explained variability as a fraction of your overall variability. I hope that makes a little bit more sense because it's also called as a synonym of the R square, you have the proportionate reduction of error. And that's actually, you will find this in the synonyms. If you look at the synonyms of an R squared, this is one of the synonyms. And I find that actually a pretty good term because it kind of really makes it very obvious what it is. Does that help, Shita, as a concept?
Yeah, yeah, and I also watched some videos on it that was very helpful as well.
Okay, cool.
I was just wondering if we could do like just pick a couple of points and I could see how to do it by hand.
You want to do it by hand? Absolutely. Let's do that. Okay. I actually have a very, let me show you this example. That's a nice one. I actually do the calculations with my undergrads. Let's do it. Maybe this actually makes it, maybe this is actually not a bad idea. Let's do that. Good idea. Thank you, Shita. Hold on. Yeah. Okay. Okay. The following example here. We have 10 individuals that are essentially having a certain number of stressful life events. So this, these individuals have basically 10 different scores on back depression inventory. So now if you want to calculate in the first step, you want to calculate the correlation coefficient, right? You want to have the correlation between both of these. So if you want to calculate, so first let's do a characterization of that. So we do now mean, average of this, average of this. Oops. We want a standard deviation of this. Or the standard deviation of this. So essentially you're getting now here the characterization of your cohorts. Now you basically want to have a correlation coefficient, which you can easily do with correlation. You have an array 1 and an array 2. That gets us a correlation coefficient of 0.58. So as well, no, let's not do that. So now you have 0 stressful life events, 1 stressful life events, 2 stressful life events, 3 stressful life events. So now you're basically, you are now calculating. So this is your dependent variable. So this is your x. So now you want to calculate your y. If you want to calculate now your y, you will need to first standardize your x. So you need a standardized x, which is essentially to be calculated as 0.
Just to clarify, Professor, the depression inventory is the y?
Excuse me?
the y-axis is the depression inventory, and the x is the stressful events.
Correct. Yes. So
Okay.
the hypothesis. Yeah. Sorry, I'm jumping back and forth because I wanted to focus on the calculation. So the idea is that somebody who has more stressful life events will have a higher increase on the back depression inventory. Will be more likely to be depressed. So that's the research question. I'm jumping ahead, so that's why this is a little bit out of context. Sorry for that. Okay, so we want to calculate, we want to standardize. Standardization, as you know from pub 620, standardization is done by x minus mean, and this is just a quick little overview on how to do this. So this is not, so we have done different ways of doing this with the least square estimation, but I'm just going quick. So we're getting here set x. So this is set x, a standardized coefficient for x for the 0. Then, oops, I'll log this in. 39. What's this? Okay. So now we're getting a quickly changing set x. These are the standardized x's, x values entries. Now we do set y. Now we want to calculate, and there's a relationship between set y, which is essentially set y hat is r multiplied by. And this is mathematically, this is now employing the arithmetical principle. That's just quickly back of the envelope calculation. This is not mathematically as beautiful as in the slide. So you can basically now calculate set y hat by multiplying, by doing r, the correlation coefficient, multiplied by a set x. So this is a quick way of calculating this. So you essentially end up now by doing set y hat, by calculating now this multiplied by your set x gets you to set y. And again. And he does it again. Okay, done now. So these are your set y hats, and the actual y hats are then being calculated by calculating. So you have the calculation is x minus, so this is y minus mean of y divided by standard deviation gets us there. So if we do now set y hat multiplied by standard deviation plus the mean, this will essentially get us a y hat. No, this time I did it before. We have C14, C13. And now we're calculating for each individual entry, we're calculating now our back depression score. So this is quick and dirty back of the envelope calculation of a linear regression. So this is basically taking the formula that is shown here on how to calculate the coefficients is essentially to some extent, so this is a least square estimation. Right? So you have this fraction here determined by the way I'm getting to. So we can do now a y hat that essentially is now our predicted y hat. So we're getting now from intercept. We know the intercept is now 0.95. That's the intercept equals this, and the slope is 1 minus 0. That's your slope, right? Because it's the increase from 0 to 1 or from 1 to 2. But so you could alternatively, you could also do this one. It's still 3.2. So this is now your calculation. This is now your actual model. And so now with this model, you can now essentially calculate a y hat for the entire. It's actually your y hat. So the y hat is basically now. Let's do this here. So y hat is now this intercept plus slope multiplied by your x. Sorry, multiplied by x. M9 multiplied by B2. No, that's not correct. It's M10. M10. Makes sense, right? So we're calculating now. We're calculating now for each individual, well, $M, $10. Okay. We're calculating now for each individual our actual predicted score. So now this is now our prediction. So now we get in the first line, we need now our sum of squares. That's the next thing we need. The sum of squares is now, this is actually squared, it's actually squared deviations. So this is now, we want the y, this minus this squared. So this is now the deviation of the prediction from what we actually have seen. So this is the difference between y minus y bar. So now we want, this is our squared deviation. So our sum of squares now, our sum of squares total is now the sum of this. 788.1. And now you have residuals. And these residuals you want to calculate by calculating y minus yi, oops, as in the formula, squared, right? Those are our residuals. So now we're calculating our yi, this is this, that's our y, minus yi, and we're squaring this. Oops, squaring it. This is now our SS regression. Now this is SS residual. This is some of this is now our leftover variability. This is what's left. Right? So now if we want to know now the left, the actually explained sum of squares, this is now this minus this. We're now calculating our sum, our R squared is now, as I said, it's the explained variability divided by the total variability. And this is essentially 261 divided by the 788. And this gives you an R square of 0.33. I know this was fast, but rewatch the recording, do the calculations. It's a very good exercise to actually do that. And of note, since this is a bivariate, correlation, you can also do this squared and you have the same result.
And the squared deviation. Oh, sorry, go ahead.
No, I was saying it's really helpful to see it done this way.
Yes, I had a feeling that this would really help. That's why I went through that exercise. I do this with my undergraduate class, and it's like it really makes it very logically. And like with the coding, you don't see it as with Excel, and we're all kind of used to Excel. So I thought it would be a good exercise to do that. Okay, does that make the R-squared here? Hero, let's put it that way. Because now we have, in addition to that, you also have to factor in the variance inflation factor, and you basically you have. Are we talking about this already? Yes. So we did. So this is the same. This is the same exercise, right? So we're basically we have now the variance of y equals the variance of y hat and the variance of the error. And this is the same situation, right? So we have the variance of y, that's the total variability. With the variance of y hat, that's our variance regression. Now we took the total and we subtracted this residual error. And then you basically just go ahead. And no, we didn't talk about adjusted R-squares yet. It will come, it will come. So the adjusted R-squared is essentially then a next step to the R-square. We basically you add a term for the so-called variance inflation factor, where basically you get an inflation of your R-square and then you estimate of the variance and your R-squared, the consequent R-squared, by adding more and more parameters. Because as you can see, the more parameters I will add now, the more I will explain of the variability. Is that necessarily a good thing? No, not necessarily, because you may also artificially inflating that explained variance, whereas in the end, you end up explaining more away than you should have, and you overfitted your model. Therefore, you have an adjusted R-square where you penalize your R-squared estimate by introducing and implementing the so-called variance inflation factor, which we will discuss then in lab 6. So, but let's let it rest at this point. I hope this was somewhat helpful. Do you have any other questions? I'm a little bit on time rush, so but I'd happily discuss another aspect if helpful.
Yeah, I actually have to get going, Professor. Thank you so much.
You're very welcome. Thank you for coming on, and thank you for the questions. Be in touch via discussion board. Zoe, any other question from your end?
I guess I mean, this is my first time coming here, which I really should have come more, but I'm seeing from this discussion that it's much more of the actual, like the mathematical based, but when I've been watching the lectures, I've been overwhelmed by the by all of the R coding that seems to be focused on. So because I'm considering retaking this class instead for next semester, because I think I'm quite behind on the R coding, but I'm wondering because the mathematics, I think I understand better. I'm wondering if going from here into BIOS2, is it the mathematics really that's what I want to carry over with me, or is it the R coding? Because I guess the R coding I could also learn in other ways too.
Yeah.
Like, what do I want to focus on?
Bluntly spoken, the mathematics. How to employ it. That's my 5 cents. The R coding, there's also an introductory R course, I believe, this summer. Try, maybe you can still get into that one. Also,
I
you
saw
have
that
the data
one was
camp.
going, yeah.
Yes. Marcel and Pino, they have designed this lab. Marcel is a great instructor. I highly recommend it. So if you can still get into that course somehow, I don't know what the possibilities are. I can't comment on that, but I'm sure you have a chance. Also, data camp. You have the data camp invite, right? Do the data camp, go through the codes. We can go next week. Let's do this week I'm a little cramped. So actually, I have to squeeze in already Wednesday again at 5:30. It's for me difficult because I do it next to work, and I'm really trying my best to be as accessible and as available as I can. Of course, schedule one-on-ones if there's really something. Play around with it. Don't get discouraged from the R coding.
Okay.
I think it's doable.
Okay.
Utilize the lecture codes. So when you run the lecture, right, and you knit the lecture together, go back, look what code in the lecture is corresponding with what you see in your R code.
Okay.
Because the codes are all there. They're all there. If you understand the mathematics, you can master this class without a problem.
Okay. All
It's
right.
the
I think
principles.
that's
The R coding,
okay.
You're not failing for the R coding, right? It's like you need to do the research note. This will be a lot of work, but it's like it's know how to employ it, right? If there's a problem with you fitting a model, it's like I can explain you how to fit a model in 10 minutes. That's not the problem, right? It's really not the coding comes to you while you're doing it. Coding is learning by doing. But the underlying theory, that's where the money is.
Okay, so that's really what to focus on, and as long as getting that out of this class and moving that into BIOS2, because I want to just make sure I have a strong foundation.
Yes,
and as long as it's the math, then I think that I'm more confident on it. Okay.
No, I think
right.
I think if you really dig your heels in, you're taking EPI too, but
or I'm taking EPI
okay,
1 and this. Yeah,
it's a lot of material, right? And summer course is very intense. But again, it's like I'm here. I'm here for
you. Thank you.
If you dig your heels in, we're gonna get you through. If you do the work, we'll get you there. Don't worry.
Okay. All right. Well, yeah, that's I guess right now my main thought. All right, I'll make sure I go over the rest of the material. I got through